So, hello everyone. I hope you can hear us. If you can't, please let us know. But welcome to our webinar on stormwater harvest and reuse, our updates to the Stormwater Manual. Thank you very much for joining us today. We have a lot of good information to share with you. This is Ann Gelbman speaking, and I work here in the Stormwater program. So we're really excited to get this moving here. If you have any questions or difficulties or anything, just make sure you use the chat box. On your screen, you might see a Q&A and a chat box. It's easier for us to respond to you if you use the chat box, so please do that. And we will try and answer your questions during the webinar. We have a few breaks scheduled throughout the webinar to answer any questions that come in. And if we don't get to your questions, if we're not able to answer them, all the Q&A will be posted in the Stormwater Manual. We are offering 1.5 professional development hours. You'll be able to access that certificate once we post it in the Stormwater Manual. If you go to the webinars page in the Stormwater Manual, you'll see that certificate there, as well as the PowerPoint presentation and other information that we will post there. We are asking you to fill out a survey right after the webinar is finished. It will pop up on your screen after the webinar, and we really appreciate your feedback. We welcome your ideas on how to make improvements to the webinar. Last time we had the session on infiltration, we received over 100 responses, so we really appreciate that. And if you would just take a couple minutes after the webinar to fill out the survey and hit submit, that would really be great. We have at least one more webinar scheduled for mid-March. We're going to be doing an update to the Minimal Impact Design Standards Calculator, and let us know what other topics you're interested in. You'll have an opportunity to do that on the survey. You can fill out what other topics you're interested in. And this is a screenshot of the Stormwater Manual. All the events will be posted in here. You just look on the left column under events, and you'll see the future webcasts that we have coming up, and also past events. The recordings will be there as well. Okay, so our presenters today, in the room with me is Megan Funke and Brett Emmons with EOR, myself and Mike Trojan with the MPCA Stormwater Program. Mike is the go-to person if you need any information on the manual, and the link is there for the manual, but it's easier if you just do your Google search and put in Minnesota Stormwater Manual. So the PCA executed a work order with EOR to do some work to update the material that we had in our Stormwater Manual on harvest and reuse. We felt that it was necessary to update the information because a lot of things have changed regarding this topic, and we wanted to provide you, the practitioners, with the most updated information. So first, we asked the consultant to provide an overview, definitions, uses, applicability, kind of general information. And by the way, Megan and Brett will be going over each one of these individually after I get done with the introduction here. There's guidance on design elements, construction sequence, operation, maintenance, and monitoring, water quality considerations, environmental concerns, costs, calculators, credits, case studies. So the team for EOR is listed here. It's Megan, Brett, Derek, Steve, Paula, and Britta, and I was the project manager for this particular work. I really want to thank the technical support team that we had. We asked a group of people to help us with this. They were able to review all the documents that EOR put together. Anita Anderson from Minnesota Department of Health, Tina Karstens from Ramsey, Washington, Metro Watershed.
We lost our audio somehow.
We lost the audio?
Yeah. I don't know that message.
Looks like people are saying we lost audio. We're going to, let's see.
Some people say it's fine, some people say not.
All right. Okay, well, we're just going to keep going because a lot of people are saying they can hear us. So if you lost audio, try logging in again. Okay, back to our technical support team. Tina Karstens, Ramsey, Washington Metro Watershed District. Brian Davis with the Met Council. Sharon Doucette with the City of Woodbury. Stephanie Johnson with Mississippi WMO. Paul Moline with Carver County. Wes Saunders-Pierce with the City of St. Paul. Dave Stark, Rainwater Management Solutions. Todd Smith from our agency. Mark Zabel from Dakota County. And Nate from Capital Region Watershed District. So thanks again to that technical support team that helped us review the documents. Other contributors to this work, Tim Malooly and Rich with Water in Motion. They helped a lot with photos from the Eagle Valley Golf Course stormwater system. Dan Curley and Mark Maloney from the City of Shoreview helped with photos with their facility, and then Kristen Asher with the City of Richfield helped with some cost information. Here's the presentation outline. The summary of information, we're going to tour the Harvest and Use Reuse section in the manual. When Megan and Brett are presenting, they're going to be doing a lot of back and forth with the PowerPoint and the actual content in the manual. We will be talking about the Harvest and Use, the new information or the new MIDS calculator that we just released a couple weeks ago. And like I said earlier, we will have breaks for Q&A throughout the presentation. All right, I am going to turn it over to Megan.
All right. As Ann said, I'm Megan Funke. I'm a limnologist at Emmons Resources. And I've been working on Harvest and Use for about 5 years. Brett and I started putting together a literature review and a calculator for the Minnehaha Creek Watershed District, Mississippi WMO. And that's how we gained a lot of information about use and was contacted by MPPA to help update the manual section. So here I'm going to start out. This is the opening page for the wiki page for the Harvest and Use. And you can see there's an outline of all the different chapters within the manual. All right, I'm going to apologize for any errors we have at first. It might take a little bit to make this smooth, going back and forth between the PowerPoint and the wiki page. Here I'm just blowing up that bulleted list of all of the table of contents for the page. And if you notice, what we'll end up doing is going through the pages in clumps of 2 with a chance for Q&A that you can put in that chat box, as Ann mentioned. So we'll go through the top 8 bullets, and then we'll pass it over to Mike Trojan for this MIDS calculator section information on the bottom. Notice there's other sections. A lot of these are just links or references, some technical support, and then there's a couple pages that are still in progress. So starting with the overview, this is the first section of the manual. We wanted to spend a little bit of time here. I think our understanding of Harvest and Use systems has expanded within just the last several years as more systems are going in place. Nationwide, a lot of effort is being focused on understanding how to make these systems more efficient, more usable, understanding risks. So you'll see throughout this presentation, we'll come back to this figure just describing the general layout and the components of a Harvest and Use system. And we'll use these terms a lot: storage unit, collection systems, distribution systems. But in the overview section, first we'll talk about some definitions, some terms that we'll use that we spent some time doing this update and with the technical group coming to some sort of consensus on how we want to describe things. And then in the overview, there's some broad information about, what can you use harvested stormwater for? Outdoor, indoor, what are the benefits? What are some major codes and standards you should be aware of? And what are some key considerations when we think about this type of system? So,
let me just interject in terms of definitions and in the title of the entire section. I think it's worth noting that around the nation and the continent, there's still some terminology questions, what pertains to what. A lot of times rainwater is considered something that might be caught on a rooftop, but is not interacted with the parking lot or the ground. Stormwater would be a more generic term for any of those sort of water sources, and we wanted to make sure we covered all of that in this manual. And then reuse has been a common term that sometimes does get mixed up or conferred with wastewater type applications. So there's been a recent move towards trying to use harvest and use as an alternative terminology, but both terms are commonly used out there, so we just made sure all that is covered within this chapter update.
yeah, so like Brett said, so here's the definition page. We wanted to highlight this. So often we think of this in terms of rainwater harvesting, but rainwater is a little bit different than what we may think of stormwater. Stormwater encompasses all of the rainfall or snowmelt that runs off of surfaces. Rainwater is specific, and when we talk about harvesting use, to just the rainfall that falls on a roof surface that we can collect. The water quality of those two sources are a little different. So that was a key distinction we wanted to make. And as Brett said, the term reuse, some like to call it harvest and use, is becoming a national trend. So we've defined reuse, but also up here we say beneficial use of stormwater. So we're harvesting stormwater and we're using it again. We're using it for some other purpose. Two other terms I wanted to point out revolve around treatment. So here we have pre-storage treatment, pre-treatment, post-storage treatment, and just general treatment. When we get into the water quality and treatment page, this will become a little clearer, but generally we have some sort of pre-storage treatment upstream of our storage unit. This is some typical pre-treatment type BMPs, but then we also can have some other sorts of pre-treatment and post-storage treatment. So pay attention to some of these terminologies in terms of treatment, because we have multiple treatment systems within a harvesting use system that is different than some other stormwater BMPs. Okay, all right, that works. We're back. Okay. Use this link. Now we go to the actual overview page. So some things I wanted to point out to you. There's beginning paragraph. We spent some time thinking about wording this, and I think it's useful just to read. It kind of summarizes some key aspects of a harvesting use system that are important for understanding how to think about the design and what operation maintenance and treatment needs are required for these types of systems. So here's where that image is found that we've shown in presentation. You need to use that for other purposes. But again, here we have this harvested stormwater source definition. You know, rooftops can come from roads, can come from any sort of stormwater that we can collect, and then these beneficial uses. So commonly we use it for irrigation or flushing of toilets, but in the future it might become more common to start using it for other uses like washing and bathing, cooling, even drinking water in some extreme cases. Here the paragraph just talks about the source area of where you get your harvested stormwater really determines the quality of your stormwater and how you might be able to use it. And that plays into all these water quality considerations and treatment needs. We get into the quantity of runoff that you can harvest from your site and how often it occurs, and this really affects your storage unit size, your water balance. There'll be a calculator page in the future that really helps you navigate that process. That's a key step, is understanding your water balance. And another key consideration we just mentioned here that gets into a lot of the design components is that you're harvesting your stormwater from a certain area. It has different water quality based on what you're harvesting from, a roof versus a parking lot. And you need to somehow match that water quality with your water quality requirements for your future use, your beneficial use. So treatment needs would be very different if you're irrigating versus flushing a toilet or trying to use it for potable drinking water. So we've summarized this in this use system matrix. So here we go through the beneficial uses. We have our outdoor, our indoor uses. So, you know, flushing, irrigation, fire suppression, cooling, washing, as an example. And we talk about just some, you know, health criteria requirements, this treatment needs, and level of effort needed to get to that treatment versus, with your source water being rooftop or from stormwater. So, for example, if we're using our water for irrigation and there's low exposure risk, if our source water is rooftop water, we need minimal treatment. If it's stormwater, we might need minimal to maybe medium treatment. So as we go through the manual, this theme will be recurring, and this chart will become useful when you're starting to think about feasibility of these systems. All right, so in the manual then, we go through outdoor uses, indoor uses. I want to draw your attention to, I've already forgot, I made a note for myself. Up in the right-hand corner, there's always a page content, so it goes through the outline of all the different uses.
Very helpful.
So you can see here, we just described outdoor uses, indoor uses. I won't go through that. It's quite a lengthy page, as we will find out. If we go here to some of the benefits, this is an interesting section, and just to expand your thinking of harvest and use, when you think about when you might want to use this system and how you can gain support for it. There's many benefits from reducing impacts of urbanization, you know, reducing peak flow, reducing volume, reducing water quality, conserving potable water demands, alternatives to potable water, reducing groundwater withdrawals. Another key consideration is this type of BMP is one that can, in a treatment train, can also increase the lifespan of downstream stormwater infrastructure, since a lot of the water stays on site as irrigation. And then there's also energy, education, environment, other economic benefits of using a harvest and use system. In this section also, we briefly have a link to the plumbing code. There's also another section on this later on in the water quality considerations. I'll pass over that. And then I just wanted to go through, at the bottom of this page, we also went through some key considerations of the system. So again, it has different treatment requirements and more intense treatment requirements than other stormwater BMPs. The storage versus supply that you need, how much you can store, how much you can harvest versus how much you need, constant versus occasional use needs, whether it's flushing a toilet, which would be year-round, or irrigation, which is seasonal. Drives your design. There's cold climate considerations, draining your tanks, making sure your distribution and all your pipes and irrigation systems don't freeze or pumps don't become corroded. A lot of different site constraints that we wouldn't have to think about with other BMPs. And then a big one is public acceptance. We've talked a lot about this. I think we often use water and we typically just rely on potable water, but we can use storm water for other uses like flushing of toilets and doing some wash water where we don't need to use potable water, but there's a perception that stormwater is dirty and dangerous, and so there's a big hurdle in just trying to change that public viewpoint. I think we've made a lot of progress. At the bottom of each page, there will also be some resources, reference links. There's a lot of information already out there. Please, if we've noted it, it's a useful tool. Please use these. We didn't want to rewrite everything that's already out there. There's a lot of really great existing work. Met Council has a reuse guide that we reference a lot. There's a lot of other state guides, work in Canada, US EPA, that we've relied on. So then we go into the design criteria. This is another big portion of the manual. So there starts with an overview. We go through the different design phases. And let's go to the manual. So this is the design criteria webpage. And I wanted to point out this chart right here. We'll walk through this. But it starts out in this overview. If we go to the page contents, there's an overview of the broad phases of design. This is a very iterative design process for stormwater harvesting use compared to some other BMPs. Later on in the manual, there'll be more detailed information about each of these phases. I'm not going to show you this detailed information, but I'll walk through this overview of some of those key steps. So if we're in this diagram, so we have feasibility phase, pre-design, and design. And there's different things that we need to look at in each phase, and whether or not we can meet these needs depends on whether or not we can move forward in our design. So not every site is feasible to have a stormwater harvesting use system. So one of the key ones is to identify your system goals and objectives. So I spent a little time here. Some of your goals can be qualitative. You know, we basically want a system to reduce potable water demand, or we want to utilize stormwater as a resource. Or you can have quantifiable goals. So, and this really drives what your design will look like. I'm putting a lot of emphasis here because, as you see later on, you have to know what your goal is in order to design your system. So starting out knowing, I want to capture 90% of the stormwater runoff from a site. That will help you determine how you size your system and design it. Maybe we want to reduce phosphorus loading by 80%, or use it to meet half of a building's soil flushing demands. So that's a key step. Next, there's these site considerations. There's this table in here. We've listed some key considerations. For example, are there any buffers, existing buffers and setbacks? We have a notes column that talks about, okay, identify these setback distances from wetlands, streams, shorelines, et cetera. And then what potential constraints could there be on the design? So is there any portion of maybe your catchment area or your irrigation area that you can't actually apply water because it's within a setback? Next is to figure out where your water is being harvested from, or your source area, and what your expected source water quality is. Again, this is really high level. So our source areas can be thought of as hard roofs, green roofs, paved surfaces, or just a green space, and whether or not different pollutants, nutrients, bacteria, metals, fluoride, the amount of pollutants from these source areas varies. So your stormwater, your harvested water has very different water quality depending where it comes from. So the filled-in dot is expected high concentration, the open dot is lower, and then no dot means it's not really expected to be found. So for example, you might have bacteria as a pollutant in some of your green spaces from wildlife, whereas hard roofs, maybe metals might be a concern.
Reference to other parts of the manual, correct?
Yes, in water quality considerations, you'll see that come up again. There is some overlap. Here again, we just go through this table. Is very similar to what I showed you previously. You can look at your beneficial use, and then you can determine what sort of treatment level might be necessary. So essentially, a big question at the beginning is, what treatment might I need and how much? That'll dictate cost and the complexity of your system. And then another key element is to consider at the beginning for feasibility, what level of operation and maintenance is needed? Who's going to be responsible? Do we need a licensed professional to do any of the O&M in the future? How often do we need to do it? And how intensely is the system need to be operated and maintained? I think we can design a lot of really great harvesting use systems, but at the very beginning of the project, this should be one of the first conversations to figure out who's going to be responsible.
I need to use the mouse for a second because I'm sorry for the interruption, but I need to send a message to all attendees because some people are still having trouble with the audio. You can keep talking if you want. Sorry, you guys. Pause for a second. Think of some good questions and put them in the chat box.
This is one of the more lengthy sections of the manual, so it takes a little time to get through this one.
Yes, they want all these as well.
All right. Here we go. Keyboard back. Okay.
Okay, so that's the broad phases of design. I'm going to go back to now this is a very long section. You can see where my mouse is. So I'm not going to go through the rest of the page, but you get more detailed information about all of the design phases on this webpage. That gives a flavor of what there is. Okay, just going through this diagram a little bit. So I walked through this feasibility phase. These are some of those key things you need to ask yourself at the beginning. And the point I'm trying to make here with some of these arrows is that a lot of these initial steps impact later steps in design. So now we get to pre-design where we start to actually get some site survey information. We do a preliminary water balance of your storage unit, supply demand. You start thinking about permit codes, what specific treatment requirements are needed, cost, can we even afford it, and then are there any risks? And then if we still think that this is feasible, we can meet the goals and objectives, then we move on to the design phase and we start to specifically design our system, starting with the storage unit, collection system, how are we going to get the water from the surfaces to our storage unit into distribution, what sort of pre-storage, specific post-storage, and then our distribution system. So all of these, for example, site considerations impacts your site survey, your water balance, which impacts your storage unit design. So the point here is an iterative approach. This diagram is on the website. I think it's useful to try to keep track of all of the things that you need to be considering at each phase of your design. Again, for time, this will be in the PowerPoint, but I'm going to skip over this. So you have your feasibility, pre-design, design, and then we get into implementation. There's some pre-construction meetings. These are really important to make sure all the different contractors and engineers are on board with the type of system and what it might look like. Permitting, signage, testing, commissioning, operation, maintenance, that's a whole other section. So then I will move into Q&A right now at the end of design.
No questions yet.
No, wait a second. When you are talking about hard roofs, are you referring to asphalt, shingle roofs, or steel?
All of the above. Hard roofs is differentiated only from green roofs, which would be some sort of grass or plant or just impervious soil matrix or pervious.
So then I'm trying to remember, do we, in the water quality section of the manual, do we provide information for these different types of hard roofs?
Yes, and actually that is in the design section. There's information about all of these specific things, your storage unit, what the material might be, some advantages, disadvantages, water quality off of different roof surfaces. Yep. Yep. There's a lot of information in this wiki page. We could spend all day on the specifics, but we wanted to use this webinar to actually just guide you through the page a little bit, so when you go into it online, you're familiar with some of the sections, but note in a lot of these, I might only go through the top part, but there's a lot more specific information further down in the page.
Another question, can you define a brown roof? Which is a brown roof, which is basically a green roof without the green.
Oh,
yeah.
Without the plant, soil media, but
just soil media.
Soil media. Yep.
Plant. Yep.
That's a good question. We actually looked for a definition of that, and it was difficult to find. So, yeah, that was a good question there. Are there any other questions? Please use the chat box if you have them. Seeing none, I guess we move on to construction.
All right. So the next phase, after overview and design, is this construction sequencing. So I guess what we have in this page is really a pretty simple step-by-step sequence of typical construction elements, and in the sequence they typically occur, and then a sample inspection report. And I guess something we just wanted to share is really in these harvest and use systems, none of the components are necessarily new. It's different than other BMPs and how they're put together. And each system is going to be very, very different. Whether or not you're utilizing existing infrastructure, if you're using a storage unit of an existing pond or you need to construct a new one, if you're using rainwater versus, runoff from the ground, that's going to dictate your construction sequence. So basically what we're trying to do is just get an example of these steps. So when you move forward, you just have a guide to make sure you're not forgetting any steps, but just think it through on your own project. Go back to the in the manual. So this is the construction page. So this is a much shorter page than others. So it just has a step-by-step sequence and a link at the bottom for this construction inspection report. So I'm just going to verbally walk through this very briefly, but starting, at the beginning, there's the key step of making sure you have all the license and permits you need and approvals. Make sure you're following the codes. Another one, we've mentioned this in the implementation phase, but our technical group strongly emphasized this as we went through the manual, but a pre-construction meeting is critical. These meetings very early on in the project. Harvest and Use systems are a newer BMP, so the actual contractors might not be as familiar, and they should be on board with the goals of the system, understand that how the components go together. It's very specific, so there's no deviations, everybody's on board. Think about site access. Again, you still need to install erosion sediment control BMPs. I think something that's different from Harvest and Use compared to other BMPs is at the end you have a lot of components being connected together. So in construction of the different pieces, are you going to construct your storage unit first? Are you going to get your collection system with your conveyance and your gutters all connected together? And if so, as soon as they're connected to the storage unit, how do you make sure you don't have any pollutants going into your storage, or you're not getting water filling up when you're not ready? Things like that just to think through. Again, there might be some pre-storage treatment structures and systems you need to put in place, gross solid removals, some large solid filters, construction of your storage, so it could be a storage pond, an above ground, a below ground tank. There might be other things like footings and buoyancy protection devices that need to be put in place. There's the distribution components. These are the pipes, the pumps, the valves, the treatment system, other utilities to get your water from the storage unit to your distribution actual end use. There's post-storage treatment systems. These often are now sold by manufacturers as one big all-encompassing system that has pipes and pumps, and there's manufacturer warranty specifications on how these should be installed and maintained. All along you should be performing these interim tests and inspections to make sure that all the pieces are installed properly, and you're protecting your pipes and pumps before all of the treatment systems might be in place and operational. With any construction, the stabilization of your overflow and discharge when you're bypassing your storage unit, inspecting and cleaning all of your conveyance and storage elements, and then documenting all the tests, completing any of your permit and approval conditions, and then, and this is a critical one, number 14, don't forget it, preparing the operation and maintenance documents and making sure that those documents are in the possession of people that are responsible for maintaining the system in the future. Inspection report, I'll open this up. Again, when you do this from home, this will pop up as well, so it's this link up here, the .doc file, open. I think it's at home. Downloading, and it'll pop up as a Word document. This is just an example, but things that you might need to keep track of for this type of system. There's going to be a lot of players involved, the system supplier, the engineer, the organization who's responsible for maintenance, the contractor, all their contact information, and then just some key inspection items to consider. The conveyance system to the storage unit, is it installed? Is the catchment area what you think it's going to be, so you're not getting more or less water to your storage unit than you expected? Pre-treatment structures properly installed, storage components, what are your discharge and overflow routes look like, your distribution components, your post-storage treatment. There's other things that need to be in place, like insect and rodent screens on pipes and other openings, and then just making sure everything's clean and passes tests. So that's construction sequencing. Now we get to operation and maintenance. I've mentioned this several times, but this is another large portion of the manual just because of the emphasis that both we deemed in this element and also the technical panel. So these are the operation and maintenance. There's agreements, who is the responsible party, different activities that need to be completed, what happens when the system's decommissioned in winter and started back up in spring, how might you track all of this information? There's a lot of moving pieces and parts and people to keep track of. So we have some sample forms and a summary table of operation and maintenance. We'll go to the manual. So here's the table of contents. Again, we have these agreements. This section 2, I'm not going to walk through this. You can see the start of it right here, this operation and maintenance plans, but it's just what all needs to go into these. It's a list of all the elements and plan documents you might need to be collecting as you're designing and starting operation of your system. But there's a lot of detailed information in here. Again, winter decommissioning, tracking, and inspection forms. So I just wanted to walk through this operation maintenance agreement. This is a really key aspect of these systems and ensuring that they work in the future. So at the start, the responsibilities of the owner in operating and maintaining the system needs to be clearly stated, described, what the owner is able to perform, if there's any third party that needs to do any of the inspections. This might be city required, any activities that need a licensed plumber. And then another key one is how might these responsibilities transfer if the ownership of the property or the system changes in the future? And then how are you going to provide for ongoing operation and maintenance that you've laid out? Who's going to do it, how often? And I mentioned this too, for funding, often you need these agreements at the onset of a project. So this is often done in a feasibility phase. Okay, I'm going to skip over some of the detailed information about all the different, components that might go into an operation and maintenance plan or manual, and go to the summary table just after this section. So we summarized all the information in the preceding section that I skipped over by component. So we have the source area, collection system, storage system, treatment system, distribution system. There's a column for time frame, things to look for during an inspection, and the type of maintenance activities that are required. So for example, for your source area, every year, think about, has anything changed in your catchment area? Any pollution hotspots that might have happened, some development that might change what sort of source control BMPs or pre-treatment or treatment devices are needed? Is there any damage to your roofing materials, overhanging branches, repair or trim? Another example is in your treatment system. If we go to kind of some of the ongoing maintenance, for example, twice per year, you need to check for accumulated dirt and debris in your pre-storage treatment components. Look for leaks, clean and repair as needed. And then another key one is the actual treatment components. Oftentimes there's manufacturer specifications about replacing some of the consumables, filters, cartridges, bulbs for treatment, and recording and keeping track of that. There's some winter decommissioning aspects based on your component that you need to think about. So for example, your storage system, at wintertime you want to drain all the water, disconnect any downspouts, the electrical supply, and shut off your makeup water supply. Another key aspect is tracking of your operation and maintenance activities. I think we talked a lot as we went through this, the manuals. In the past, this type of DMP got a bad rap, mainly because some of the operation and maintenance didn't occur. So they'd be constructed and it wouldn't be clear who's responsible for what, or things wouldn't be repaired as needed, and so they just kind of fell into disrepair.
Yeah, or even as simple things as people not really operating the tank very well, so a tank sitting there full that receives another rainfall and just overflows is really a BMP that's not functional, so just making sure that there is someone on top of, you've got a bit of a water balance that you're trying to manage here, so making sure that the system actually is operating as designed, so that as the water is captured, it's also being used, so that then it's ready for the next time it rains. So simple things, but it's a little bit more interactive than some of the other passive stormwater practices that have been more common.
Very active operation and maintenance. So record keeping, having inspection forms, and these maintenance logs are very, very important. So, for example, I'm just going to open up this middle treatment system maintenance log, just an example of things to consider. This is, very template, but you're welcome to use these Word documents and modify them however you want, just to start. So, for example, for this system, there's a UV light that needs to be changed. There's a spot that specifies how often, and then a place to keep track of that to see if it is. There's a filter, there's a cleaning of the first flush diverter, there's a need to check for leaks and to test for bacteria. So for each of these, you can specify how often and then keep track of this in some sort of maintenance logbook to make sure that these are being completed. Sometimes it's good also for a lot of these consumables to keep track of, what type and supplier. Little things, but we just wanted to use this as a tool to help you remember things that you need to keep track of. So if there are any questions on the construction sequence and O&M, we're looking at the chat box now.
There's one question here. Join late, but could a system to harvest clean gas station runoff be proposed? The runoff of hydrocarbons is much more serious from the source points than imagined. So I think the question is basically getting at, can these systems treat hydrocarbons and probably pollutants in general that are a little bit more risky, I suppose?
And the answer is yes. So you'll see in our, when we go through the water quality considerations, we'll have a table in there that goes through a lot of these kind of unconventional post-storage treatment, where we get into nanofiltration type of practices, these filters that can take out much smaller pollutants and, things like that. So.
Probably one of those kind of unique, those are always kind of hot spots that you would want to use with care, but there are, if you're going to end up with some sort of a filtering treatment system, it's possible that you can filter out even things like hydrocarbons.
And I have a question, which I should know the answer to, but when you're doing your O&M major checklist in that table that you showed, different maintenance activities, but for like your source area, are there significant differences between different source areas and the type of maintenance and inspections that you would have to perform, a roof versus a parking lot? Is that information?
Yeah, I think there are differences between your source area. Really is, I guess, one of those kind of iterative types of things here. Your source area is going to start to indicate what kind of water quality you have, and in many cases like sediment load or other things that are coming in. So once you look at different source areas, you could end up in very different types of design systems. So if you're taking roof runoff, relatively low, low sediments, low pollutants, the rest of your design can be customized to that and potentially be a much more streamlined process. Whereas if you're taking it off of a site that you know have a lot of sediment moving around on, a lot of activity going on, runoff from parking lots, et cetera, that get sanded, then now you need to configure your system a fair amount differently just to be able to deal with the physical setting of those. So it is one of those cases where you kind of need to think through how much you want to invest in the treatment and operation and maintenance. And you may have originally thought you were going to do stormwater from all surfaces, but as you go through your design process, you may want to back up and say, well, if I have a very large roof, maybe I'll concentrate on treating that as one of my primaries where I'm doing my volume control, just because there's so many less issues that go with that.
This might be a good time to add that one thing that was not done as part of this work order that we're looking at doing some additional work on is looking at special considerations for ponds that are used for these irrigation systems. I know it's my impression, I'm not a stormwater harvest person, but my impression is that a lot of the stuff in literature is for tank type storage and not a lot for ponds, and there may be some special things considered for ponds. So we're going to address that, I'm thinking.
Yes, there's a lot of interest in maybe trying to retrofit ponds and do something with that, which I think has a lot of potential, but it also starts to introduce some new questions and issues that come up. And if you draw the pond down too far, are you creating new issues of aesthetics or public concerns?
And I did get a note from someone here that treating runoff from gas stations is tricky and not advisable.
And if find it on location. Right, it's part of the, what is the cost? I mean, there's probably a filter out there, but is it even going to operate quick enough and treat enough of your runoff? So that's all part of that feasibility.
Good point.
All right, with that, I think we'll move on. Again, there'll be a Q&A too at the very end if questions on previous sections come up that you have as you're seeing a later section. So don't hesitate to ask about a previous section later on. Okay, I think, and one of the things we struggled with, as you can see in the manual, is actually separating out all this information into clear chapters. As you can see, there's a lot of overlap. It's very iterative, and things depend on other components. So here we go into water quality considerations. So this is where we get into, okay, the quality of your harvested water really dictates how much treatment you need and what beneficial use you can use that water for. So there's a general description of pollutants in harvested water. This is covered pretty extensively in the manual as it is, so we're not going to spend time there. There's some seasonal considerations with different changing water quality based on time of year with salt runoff. We'll go through some of the treatment requirements. There's a National Water Research Institute advisory panel that has been utilizing lots of different states and universities and agencies all over the country, coming to some sort of consensus on how do we determine risk, how do we determine treatment requirements, and how do we figure out a way to think about those in some sort of I can't think of the word. Anyway, it'll come to me later. And then there's a brief mention again in this section of the Minnesota Plumbing Code, which went into effect January of last year. For the manual. All right, again, so if you look at the page contents of this page, so here's that pollutants in harvested water. Here's these water quality considerations of runoff from these specific source areas. This kind of answers some of those previous questions. Seasonal considerations, treatment, the treatment systems. These are these elements of this page. There's several key tables in this page that I'm going to point out to you. So I'm going to bypass this pollutants in harvested water. Where's my mouse for a second? Okay, so that top section is just some general summaries of water quality, and some of it links to other sections in the manual. That is not new. But here we, again, wanted to talk about, it really depends what your source area is. And again, we've kind of defined these 4 different types. But as you see in this table, this is going to look very similar to that table in the overview section. One thing we've added, now that we get into more specific water quality considerations, is we split out particulate versus dissolved nutrients, because that requires different types of treatment devices, different types of filters needed for different end uses. So hard roofs, green roofs, brown roofs, paved surfaces, green spaces, and now we've also added in if we're using an existing sedimentation basin or detention pond. It has its own in-pond treatment processes, so the water quality pumped out of a pond may be different than just collected off of a paved surface. So again, you can see here that, dissolved nutrients are going to be a little higher in your green roof runoff, your green spaces, and in your sedimentation ponds. Again, metals in your hard roofs might be a concern, and then chlorides and grease and oil from your paved surfaces. And we need to think about all of these since we're using the water in different ways. I think here was a question, actually, Mike you asked this, and I'd already forgotten even where it was in the manual. But here, so we get to hard roofs. There's several tables that talk about different roofing materials. Again, hard roof covers metal roofs, tile, shingles, asphalt, all these different types of materials, and they have different water quality conditions. They might have different levels of metals or susceptibility to mold or algae growth or insects living in them. There's a little bit more information about that and some concentrations of the metals that are typically found. Again, we have a few more tables that just kind of go more specifically about some of the water quality characteristics off of these specific source areas. Okay, so then we get to seasonal considerations. Again, this is, some of this they're very short sections, but just things we want to make sure people think about. Snow melt has high concentration of chlorides and sediment, so, maybe you need to divert your spring runoff so that it doesn't accumulate in your tank or damage your treatment or your pumps or distribution system. In the spring and fall, you're going to get a lot of more organic litter or organic matter that may need to be filtered out or skimmed out or treated. Then gets us into our treatment requirements. This is a big question that always comes up. Do I need to treat and how intensely? And all I'll say is right now this is a very active point of discussion nationally at the state level. So the current consensus, and this is based on this National Water Research Institute panel, is to think about it instead of source area or end use, just as your system as a whole, identifying whether or not there's low, medium, or high exposure for humans. So is there direct physical contacts with humans? Is there none? Or can we even ingest or inhale the harvested water? This will affect, what sort of site barriers, filtration, disinfection, or other treatment barriers that might be needed. So these will be guidelines based on exposure level, risk level, whether or not you need signage, restricting access, what types of filtration systems you might need, or disinfection, as opposed to a more quantitative, treat down to this level type of approach. So check back to this treatment requirements page on the water quality considerations in the future. This will be updated. A report is coming out soon from the NWRI. This is I figured we got as a draft just to show you kind of where they're at, how they think this might be presented. Again, we have some information about that Minnesota Plumbing Code, so pay attention to this if your beneficial use is within a building. And then we get into our treatment system. So one thing we wanted to point out, pre-treatment, so the source control, removing suspended solids or your coarse solids, that is already covered in a previous section of the manual, so there's a link to that section. They're not discussed here. What is discussed here in detail, which is new for this type of BMP, is this post-storage treatment. I think we were just talking about this. So here's a nice table. I believe this originally came from Met Council's reuse guide, reproduced here. It's a great table that describes what different processes. There's dissolved solids removal. I talked about that, disinfection, and some even other treatments, pH adjustments for your pump and distribution components. So, for example, dissolved solids removal. So you might need to remove these as pre-treatment for disinfection or just for your different types of end use. And there's different type of alternatives, microfiltration, nano, reverse osmosis filters, ion exchange filters. So here's where we talk about you could remove a lot of pollutants, but then it gets at cost. So here it talks about target pollutants. There's a description of capital cost, operation and maintenance level, energy needs. Some of these are very energy intensive to run these types of filtration systems. And then I really like these two, these advantages over alternatives, or disadvantages within the same post-treatment process group. So why would I choose nanofiltration over ion exchange? It helps go through that. So for example, nanofiltration, medium capital cost, medium O&M, high energy needs. But its advantage over some of these other alternatives, it requires, even though it's high energy, it requires less energy than reverse osmosis and ion exchange filters. Disadvantage is that it requires a lot of pretreatment, so that you don't get scaling and particulates, biofouling in your filter. And it also produces a larger waste stream than reverse osmosis. So for a lot of these treatment systems, you have a waste stream you have to deal with. And this gets into the active maintenance needed for these, some of these systems. Again, disinfection, you have chlorination, UV light ozonation, similar kind of comparison of these different techniques. And then there's just a little discussion. You can have some sort of chemical additives needed.
As you can see, there's a lot of, the good news is there's a lot of alternatives and ways you can try to treat this. The other side of that coin is it can get fairly costly. So I think it also speaks back to that trend towards trying to understand do the risk assessment going in. Because if you can find a low-risk type of setting, you may not need to go to these fairly high treatment type scenarios that cost a lot of money. Whereas if you're in a high exposure setting, you are going to have to think through some of these pretty intensive things depending on what your water source is.
Which is a perfect introduction for the next slide and next section, environmental concerns. So this is where we discuss, okay, how do you conduct a risk assessment and what does it cover? So human health risks, ecological risks, how might you manage risks in your design and O&M activities? And then we have a nice table in the manual that kind of walks through that. Let me go to the manual. So here I just wanted to highlight, and I hope it's in your screens you can see me as I'm using my mouse. So just point out just the definition, a human health risk assessment. You know, it's looking at what's the nature and probability of adverse human health effects when they're exposed to certain chemicals and contaminations. There's ecological risks. So how might the environment be impacted? This comes up more with this type of BMP than others, infiltration as well. When you're concentrating stormwater in one place, infiltrating into the soil, we're irrigating with dirtier water than rainwater on an area for a long period of time. What are the impacts to those plant communities, the soil in the future? So I want to point out too, there's a lot of really great existing resources if you're not used to thinking about risk. The National Academy of Sciences just came out with this really great paper looking at using greywater, stormwater for reuse. So assessment of those risks, costs, and benefits. This is a great study. EPA has a whole risk assessment webpage. It's pretty general, but goes through all the things you should think about. And then prior to the development of either of those, Australia has been a front runner in harvest and use for a long time, and they have a pretty detailed risk guide going through all the different types of health and environmental risks. This is a several hundred-page document, but is worth looking at if that's a key concern for your project. So human health risks. So we have chemical pollutants and pathogens that might affect us. There's bacteria, waterborne diseases that might grow in the ponds or the cisterns. Again, we're only starting to think about these now compared to other BMPs if we're starting to have more direct physical human contact. So there's some information on thinking about human health risks. Again, this is coming up because now we can have skin contact, direct ingestion, inhalation, if it's in an irrigation mist, things like that. Ecological risk, again, plants, now that, especially with the irrigation, there's going to be some pollutants in that stormwater runoff that are going to be concentrated, what impacts of maybe chlorides on the soil, thinking about just your system in general, how might the system affect local hydrology, that's with any BMP. And then in particular, since there's a lot of moving parts, how much do you need to treat or think about your source water just in terms of equipment degradation, in terms of fouling or degrading all your pipes and components. So here we get to this table, this managing the risk. So, okay, now what can you do? What do you need to think about? So we split it human health, ecological risk, and the different components I talked about. Source area pollutants, we've got spills, bacteria, mosquitoes. Here we have ecological risk to plants, soils, aquatic systems. There's things to think about as you're making your initial design, and then what needs to be laid out in your operation and maintenance considerations. So source area pollutants, for example, things you can do and put into your design to minimize risk, make a bypass for runoff from pollutant hotspots. Maybe not even, change your source area, what you're collecting from. There's pre-storage treatment systems. You can use source control BMPs. In your operation and maintenance, regularly cleaning out accumulated sediments and storage ponds, and then inspecting your source area, making sure nothing's changed. In terms of ecological risks, For example, with your plant communities, again, you can have some sort of pre-storage treatment system so that you have less pollutants in your harvested water, or plant salt-tolerant plant species if you think you're going to have a lot of chlorides, and that's an option. And also, operation and maintenance consideration would be, irrigation rates to optimize the saturation of the soil so you don't interfere with your plant growth. You don't want to suffocate your plants with too much water. Again, here's a link to those other resources that I just mentioned. That leads us to another Q&A section.
Okay, we have a couple questions here. Was groundwater recharge considered as a beneficial use?
It was considered at the very beginning. For this manual update, we are not talking about groundwater recharge. There's a lot of different agencies that need to be involved.
I think we just mentioned in passing in the overview section, if I'm not mistaken. Is that correct?
And if not, we may have even pulled it out. I'm not sure if it, but.
Okay. Seems like something that maybe in the infiltration section we might want to take a look at a little bit more.
I think it's something that the U.S. EPA guidance on reuse, including wastewater, talks about quite a bit, is that in cases of either stormwater or wastewater, treated wastewater, that can be recharged as groundwater. So since this manual was not going into the wastewater section, we didn't end up getting into that here as much.
Are you aware of any studies out there that have been done to look at, since this is different than, say, a rain guard where you're taking water and focusing the recharge, here you're typically applying it over a greater area. I would think maybe infiltration might be a little less significant, but have you come across anything?
I don't, and I think that could be a gap here. I think we've always wondered if we're trying to do this for a stormwater purpose and we want to try to get some of the water back out into the soil and into the plants, we would actually possibly be willing to use more water to irrigate than is the bare minimum needed, whereas most irrigation systems are set up to just kind of not overuse. We might be in a situation where we would. So it's always a piece I think could use more review, is if you applied in certain soil conditions, if you have a sandier soil, potentially you could apply twice the rates that you minimally need for irrigation, but the plants won't be harmed, and in essence, some of that water might start going down to the soil profile and becoming recharged, which again is fine for our purposes, as stormwater is your main goal. If you're trying to hoard, if you're out in the arid Southwest and you're trying to hoard water and you want to use it very sparingly, then you probably would use a different approach than we are here. So there are some kind of regional differences too around the country, around North America.
But in terms of actual groundwater recharge, potentially piping down, that is not discussed at all in the manual. I just looked back at the overview.
And I don't know, maybe this is a question for you, Ann. Are there any grant or assistance programs for these types of systems?
Yes, there are grant programs available, and thanks for asking that question, because it gives me an opportunity to put in a plug for our February 6th Stormwater Funding Workshop. And that, again, is listed in the event section of the manual, but that will be a workshop you can attend here at the MPCA, or we will be using WebEx for that as well. So there's lots of grant opportunities for reuse. So tune in to the February 6th funding workshop to find out more about that.
And I had a question. If your system is not capturing snow melt, let's say you operate it in May, for example, are chlorides much of a concern for those types of systems?
Typically, if you get out of that spring runoff snowmelt condition, chlorides are typically not a big issue. It's mostly in the winter and that first flush in that spring.
Mm-hmm. Unless you're near maybe a salt piling source, but they're getting better about, we're learning more about how better to store salt. And then some soils can become saturated and start to leach throughout the year, but again, spring is really the most important season. Okay, that last question actually leads into the cost-benefit consideration section. So it'll be cost-benefit and then case studies ending this, at least me and talking. Yeah. So here we're going to talk about total system costs, itemized component costs. We'll show you some example contractor bids, the funding sources, and then some other, financial incentives and benefits. I just want to talk about this figure on this slide. First of all, to illustrate, the cost on the bottom is in thousands of dollars. So here, this is based on the survey Ann sent out as part of this project. Just querying probably everyone listening of Harvest New systems already in place. How much did it cost? I don't think we have a good sense of these costs, in part because they're very variable and they vary in size. So they vary very drastically. So here's just the number. We had 7 systems that were less than $50,000, but we have 3 systems that were over $500,000. So we can think of it in total system cost.
I think it does speak to the fact that they are such variable systems. If you're taking brook water and it could go to an existing storage facility and you could use that for irrigation, you could have a very low-cost system. If you have a highly contaminated type source and you have to build an underground tank and do a lot of treatment to it to irrigate, you could end up with a relatively high cost. So really, they are just inherently somewhat variable, and that's what we were finding with the survey data that came back is a pretty wide range of what it might look like cost-wise.
So in these top 2 paragraphs in this page, kind of gets at this discussion, the different site setting, existing infrastructure that might already be in place dictates the variation in cost. So I encourage you to read these 2 paragraphs about what can affect your cost. If we go down to what sort of information we have, I guess I'd just point out there is pretty limited cost information. So the Met Council Reuse Guide has kind of a list of cost elements that you need to include in a cost estimate. Contact has a really nice cost summary for cistern materials, and then the Texas manual on rainwater harvesting has a few unit costs. But other than that, there's really not much available. I think you'll find, and some people may have already found this, a lot of those treatment distribution systems are sold as a package, so it's hard to figure out how to adjust costs for new systems when your cost estimate might be $30,000 for a system to $10,000, and it's not clear how those costs get differentiated. So here's this table from Contact that goes through underground, above ground tanks, different type of materials, the different costs. With tanks, there's usually a rule of thumb about $1 to $3 per gallon in terms of net cost. So it talks about some benefits, and then the size of tank these materials are best suited for. That's a really great table. Here's this Texas manual. You have a few itemized system costs. So here's a sense of what a reverse osmosis filter might cost that needs to be replaced, and a UV light disinfection system, and the cost of a bulb, if you're unfamiliar with that type of thing. And then this is from that Met Council guide. It's just lists based on phase. Collection system, storage system, below ground storage. What are all the different cost components? This is just to aid in developing a cost estimate. So, the units, and then kind of figure out which ones are applicable in your system to help you develop a cost estimate. We've provided, actually this is just some information EOR has of some past projects, just an example of what these might look like. We're trying to just give you a basic example of, okay, in this basin, and a lot of these are just our engineer estimate, here's all the list of pieces needed for, erosion control, grading, site restoration, an underground storage tank. So this is for 3 29,000 underground storage tanks. Here's some unit prices and bids. So you can see the total cost for this system was $390,000. And if you go price per gallon, about $1.46. So that's within that $1 to $3 range. That's just an example. Here's one 1,500-gallon above-ground corrugated steel storage tank. So some of the different cost components. Here now we have gutters as our collection system, a rodent guard, things like that. And so we had a total cost of about $30,000. Next, we just list some funding sources, so by source. So I guess our key here is to think creatively and try to get different partners together. I think we found in the survey a lot of this information, these are different sources people have used. Watershed organizations, whether it's a watershed district or a power agreement, they may have some cost shares. State agency grants and loans. We have the Met Council Stormwater Grant, 319. Again, this probably will be covered at that February 6th funding County funds, you can talk to cities and think about any stormwater utility fees that might help finance. There's other public financing options, working together with school districts, student housing, any sort of park system. And then a lot of systems are just privately financed as part of their new development. Yep, they're trying to meet their stormwater requirements. Often, stormwater harvesting use helps them meet those volume pollutant reduction requirements in some pretty tight sites. They can use existing stormwater ponds and reuse it for irrigation and get a lot of removal in a limited space.
And the Metropolitan Council has also been funding some reuse projects, and someone from the Met Council will be, we did include it in there. Someone from the Met Council will be at the workshop on February 6th.
And last little bit in this section, so we have a short bulleted list just to think about, there's a cost, we know the volume pollutant reduction benefits, but there's other benefits to these type of systems that might be important for, getting stakeholders involved, selling it to a city, and constituents. So, it can give you points to LEED or other sorts of certification programs. Some people have goals to achieve that for new development. It can reduce your potable water utility costs, so you can think about how this can offset existing costs as a savings. Reducing downstream stormwater infrastructure costs. Is it going to be reduced maintenance and pressure on downstream DMPs? Just in general, increase resiliency in your stormwater management, having a more broad set of BMPs and other ecosystem services that this type of system can provide. We've listed just a few as we were doing our search. There's some out of Virginia, some cost-benefit case studies. I provide some other examples of total costs and benefits to get at this kind of cost-benefit dollar per pound removal. And again, these are those links, the contact guide. Here's the link to that pamphlet where that table is taken from, and then there's a U.S. EPA cost literature review and case studies report that was done in January 2013. That's interesting. You can access from this page. With that, I'll pass it back to Ann.
Okay.
Well, we have a couple of questions here.
Oh,
or is there Q&A?
Well, we can take questions now before we get into the case study. Sure.
Okay. Is there a tax benefit or rebates associated with these systems that anybody's aware of?
Good question.
I'm not aware of that specifically. I guess one thing that comes to mind is if you are reducing your water use and you usually have a water utility water bill, that would be sort of an indirect way that you would spend less on your water bill. Mm-hmm. I'm not sure of any tax credits per se, utility credits.
And then another question, how easy is it to get the maintenance supplies like the bulbs and filters and things like that?
I think they're relatively easy. I think that's one of the check sheets it's good to list where you're getting your supplies from when you initially set up the system, and how important it is to have all the different pieces up front understood going in, so that it is an easy phone call. You've already identified with the vendor is that sells that. One reason I say it's fairly easy because a lot of these things are coming over from like a wastewater application, UV disinfection, filters, and industrial uses. So a lot of these products are out there. They just haven't been used as much on the stormwater side. So there are a lot of good products out there. We just need to adapt them to our stormwater world.
Any other questions?
How is the waste stream handled from backwashing filters?
Good question. Depends on what you're backwashing out. Sometimes it ends up going to a sanitary sewer discharge, depending on the volumes and the site. I suppose if it's not too terribly bad, you might find another way to dispose of that. But I'd say it's probably most common if you have a fairly large system. It oftentimes goes into a sanitary discharge.
Seems like something we might want to address in the manual.
Mm-hmm.
Good point. Yeah, there's not much discussion.
Oh, the questions keep coming.
Yeah, we can take one or two more.
Pretty good on time.
We are working with a local historic business here in New Ulm right now who has approached us about the potential for a permeable parking lot or something like water capture and reuse on site. Is there anything or anyone we can talk to about comparing costs before taking on the cost of an engineer? Is the manual a good source for that, or is this kind of too general maybe?
Yeah.
Probably at this point, it's a little general, and it sounds like they're mixing several different types of BMPs maybe on one site, so it might take a little
Sounds that
digging.
way, yeah. So they're trying to decide whether just to do the permeable pavement thing, I think it sounds like, or.
Oh, compare costs of permeable pavement
Okay.
versus reuse.
Yeah.
Without consulting an engineer, I don't know.
Yeah, I guess I would say that in the manual, it's generally been our approach to kind of stay away from specific cost information because it changes all the time, and so it tends to be pretty general. And it also depends on the systems that you're putting in and so forth. So the manual might be a good place to start and get general information, but I don't know if you'd agree with that or not.
Yeah, tend to. Yeah, I think it's just so many context-sensitive type things that can affect the cost that, yeah, I mean, we're sometimes a little nervous giving people just a off-the-cuff number, not knowing sort of what the situation is, because later you can find that other things come up that really influence the cost quite a bit.
The other thing that you could possibly do is talk to someone who has a system in place and get costs from them, which kind of leads us into our next slide on case studies.
Nice segue.
All right, so we are trying to develop case studies in the manual so that you all can talk to other people about what they've done and see what other organizations and cities and businesses have done with reuse. We also have case studies for the other best management practices as well throughout the manual. So I'm going to show you the link. Right now I have the Mississippi Watershed Management Organization listed in here as a case study with a couple of pictures, the name, the type. They have a cistern, kind of an overview, who owns it, who operates it, and some of their costs. There's obviously many case studies of stormwater and rainwater harvest and use in Minnesota. So I am always looking for good information, so please send me any information you have. You'll see right here under links to other case studies in Minnesota, this is actually something that we had in what I call the old guidance that I just copy and pasted in here for something. At some point in time, I'd like to elaborate on all these. So, what is the city of St. Anthony Village? I'll be putting more about their system and the Unacre Ridge Golf Course and Target Field. So this is kind of a work in progress. And again, if you have good information, please send it to me and I will make sure it gets into the manual. Any other questions that came in about case studies or cost benefit?
No other questions. Someone was wondering about submitting questions, and there should be a chat box on your screen. If for some reason you're having trouble, you could always just send Ann or me, Mike Trojan, an email, and we'll make sure it gets posted in the wiki when we post the questions later on. Yeah, and you might see a Q&A box on your screen, and we're not monitoring that Q&A box just because it's too much to monitor the chat and the Q&A. So at the beginning, I asked everyone to use the chat box for questions. Here's a question. Several of them also. Does your cost analysis take into account reliability of the system? At what reliability do these become viable?
The first part of the question I got is that how reliable would it be considered?
Does your cost analysis take into account reliability of a system?
So it must be lifespan and how often you need to replace some components. It would, and often, even in one of our examples, you see we put it over a 25-year lifespan. So that's typically the best way to do it, is to get some sort of life cycle cost.
Life cycle, yeah. We've been working with some folks in Canada lately, and they've been looking at reuse systems, harvest and use systems having one of the longer lifespans, upwards of maybe 60 years. So it really depends on kind of your components and what they look like when they might need a total revamp. But in some cases, they could be fairly long-lived systems.
Mike, I think in the interest of time, because you're last and we have 10 minutes left, Mike Trojan will be up next, and he'll be talking about the credits and the MIDS calculator, and if we have time, we can go and have some more Q&A. Otherwise, if we don't get to your questions, again, after the webinar, we will be looking at all the questions that came in, and we will be responding to them, and everything will be posted in the Stormwater Manual under the webinar page. Take it away, Mike.
Okay. Well, you're in luck today. I only have 2 slides. So we did write a work order to update the MIDS calculator, and addressing the stormwater harvest and use, reuse BMP in the manual, in the calculator was one of the tasks that we addressed. And version 3 of the calculator is now out. It's in the manual. It's plastered in a couple of places in the manual. Go to the MIDS section. You can go to the table of contents, and you'll see links to it there. But I'm going to talk specifically about some of the things we did with the harvest and use/reuse best management practice. If you recall, for those of you who have used this calculator, this BMP in the calculator, you used to put in a weekly rate of application for irrigation. We have modified that now. You can still put in a weekly rate, but also the calculator now calculates daily potential of evapotranspiration, and so it compares the 2 values, the value that you've input versus the PET, and it takes the smaller of those 2 values to calculate the volume credit. So basically what we're saying is you can't put more water on than crop demand. However, as Brett mentioned earlier, we make an exception for A soils. I thought I mentioned that here in this bullet, but maybe I address it down by. Yeah, there we go. For A soils, however, you can have a weekly application rate of up to 2 inches per week, which is significantly greater than potential evapotranspiration. And as Brett mentioned earlier, the reason for that is people who want to build these systems for the purpose of capturing stormwater, we want to encourage that use, and A soils we feel can take that extra application. We'll go back up to the second bullet here, that users can now also enter a weekly volume for non-irrigation purposes, and this volume is credited towards a performance goal. My experience with the calculator is this is a fairly small credit. If you're irrigating, you're typically going to put much, much more water on with the irrigation system than you're going to use for non-irrigation purposes. The 4th adjustment was if precipitation on a given day is less than the daily use, then the difference between daily use and precipitation is credited. So if you get a 1/10 of an inch of rain and your potential evapotranspiration for that day is higher than that, you'll get that difference as a credit towards your volume. So when you're in the manual, in the calculator, keep thinking manual here. If you're in the calculator, this is the reuse icon down here. I have a pond system set up here. For those of you who have pond systems, don't forget to put your pond in and route the water from the pond to your reuse system, because that's going to give you extra phosphorus and TSS treatment. That's not an option in a storage tank unless you're a really savvy and creative modeler and want to come up with imaginative, but I'm not trying to encourage anybody to do that. So I have 2 scenarios here. The one on the left is where I have an A soil shown here, and this is a B soil over here. And so you'll see that this is again a pond situation, so I have a very large storage amount, applying it to a 10-acre system, and I could answer no here if I said I didn't want to have a weekly irrigation rate. In that case, it would just take your potential evapotranspiration and use that to calculate your volume. So on an A soil, I can put in 2 inches in a week, and it's going to take all of that water. If I did that on a B soil, it's going to default back to either your irrigation rate or the PET, whichever is the smaller of those 2 values. We also have an input for type of crop that you have, if you're putting it on turf or vegetables or forest or whatever. Your time frame that you're going to be applying it. Are you adding water, or does it go offline? And are you adding water for non-irrigation purposes? And if you are, then you have to put in a volume for that. And as you'll see here, for those of you who can see it, that because we have that, we're allowing up to 2 inches per week on these A soils versus this B soil where we're not allowing it, you can see that this system can capture up to 29,800, I believe, or 600 or whatever that is, over 29,000 cubic feet towards the performance goal, whereas on the B soil you're at just a little over 17,000 because it's not allowing you that full amount. Pushing on the help button will take you to a page in the manual, requirements, recommendations, information for using harvest and reuse cistern as a BMP in the MIDS calculator. And it takes a little while to say that, but this is for those of you who want to know what all the inputs are, what kind of output you're getting, and it gives a couple examples also, including a new example using version 3 of the calculator. And I think that is it for me.
Well, we do have a few minutes, 5 minutes, so we do have some time for questions. If any of you decide to log off at this point, please, please, please fill out the survey when it pops up on your screen and submit it. But we can take a couple questions now, Mike.
Since reuse ponds aren't in operation all year, how do you justify meeting treatment requirements for the remaining months? Is it necessary to supplement treatments during these times? That kind of, I think that gets at a question about how we're crediting the systems, and I've had some discussions with our engineers. It is a bit of a conundrum, is that the right word?
Sure.
Because these reuse systems are not operational all year. If you use a MIDS calculator, for example, it's going to give you progress towards a performance goal, but it's really not quite right because your system's not operating all year. So the short answer is we're talking about it and we're thinking about exactly what it is we're going to have to do to give a proper credit for these types of things. I hope that answers that question.
I think in a frozen condition, a lot of times you will have more runoff generated than during the summer, but I think Mike's definitely right. Those kind of shoulder months before the vegetation has really started to come around, but things are starting to thaw out. There would be more capacity for the water to actually go into the ground, whereas maybe the reuse system isn't totally online. One thing we've also talked about is one that we've thought about in our designs is trying to set it up in a way that we know we can bring the tank down to close to empty at the end of the year. That's kind of a design consideration we'd like to do, so we build in some reserve capacity for that first flush in the springtime.
Not sure I understand this question here. Where is this treatment going to take place? Is it at existing reclamation sites? Is it something that would have regional sites to specifically treat the stormwater? Is that?
This time about the scale, if it's very site-specific or if it's a larger scale?
We might have to follow up with that question and find out exactly what it's getting there. So, can you reiterate what portion of the presentation is updated information in the manual versus existing? I think it's all.
I would say all of it. Everything we went through today is all new information. We pretty much took what we're calling the old information, and it's no longer there. We are going to be doing some additional work on modeling and the stormwater pond information that Mike mentioned earlier. So that will be added, but I would say all of this is new.
Should a general amount of 1 inch be used for irrigation calculations, or should irrigation demand be based entirely on potential evapotranspiration? I think what we're saying is you can do both. You could use 1 inch, but if you use 1 inch, you're probably going to lose some volume because in the summer months, PET is greater than that. So it's going to, if you restrict it to 1 inch, like I say, I think you're going to lose some volume.
And then you can also consider some infiltration and into the soils and being stored there. That might trickle down into some shallow groundwater or be used later. So.
And just to reiterate about the MIDS calculator, it is a simple tool designed to help give you some good good scientifically defensible numbers, but it's not a full-fledged model. So if you really want to get more precise measurements and information, there are some models out there, I believe, maybe that.
Yeah, as part of our work, we did do a review of North America and the different models that are out there. There are several out there. We kind of came, it was always, they had something that was good about them, but they were maybe missing something else. So we tried to bring the best of all that together. So I think the MIDS model is kind of built into a certain standard that you're trying to meet and tells you how close you are to that standard. But really in terms of the design, looking at how efficient you are, how empty your tank is in the fall and all those kind of things, there probably are other models like the one we worked with, Minnehaha Creek and Mississippi WMO, that will give you a little more ability to kind of user interface with it and kind of look and see what, as you increase storage size or irrigation area, you can kind of start to see what the result is in your design process.
We have time for
One more.
one more. Let me see here. I don't know which one to take.
Good ones?
Thanks for your good questions, everyone.
Will the MIDS calculator account for the amount of water supplied by harvesting versus supplement by city distribution systems?
No.
I don't think so.
No, I don't think so.
It's explicitly built in. Again, yeah, the way the design comes, as you're looking at the design, you'll be able to tell when your tank goes empty and when you then need to be thinking about a backup water supply. If your irrigation, for instance, if it's an irrigation where you definitely need to have that water. So I think it's an aid to help you calculate how often you will need that extra water, but I don't think it's actually built into the calculator currently to have a secondary source that you could sort of turn off and on.
There are some other questions, and we will get to those on the web, on our websites, make sure that we answer all the questions properly. Is that the right word to use?
Yes, as best as we can. To the best of our knowledge. And don't forget, if you need the PDHs, that certificate will be posted. And again, the survey. If you have suggestions for future webinars, please let us know. And look for the posting in mid-March on the updates to the MIDS calculator webinar. And with that,
Thank you very much. We are finished with the webinar.
Sharing.
No, yes, I'm sharing, but I can't end it yet. Here we go.